Bismillahirrahmanirrahim. Assalamu alaikum. And the lecture series of CASTEP, we are at the lecture number 6. And this lecture we will discuss about KPoints and the electronic type of KTIP calculations. So in this interface we have different things. First of all, I want to define KPoints briefly. KPoints is basically points of reciprocal space, and generally we can define reciprocal space is basically, if you may know very well about in quantum mechanics, electrons are described by wave functions, and crystals atom repeats periodically in real space. Because of this periodicity, it's more natural to describe electrons in reciprocal space. A reciprocal space is basically mathematically we can call it this is the Fourier transform of real space. So in short, a real space describes position of the atoms, while K space describes wave vector of the electrons, means momentum of the electrons. Okay, so the another thing is which is very important regarding the KPoints is Brillouin zone. Brillouin zone is basically the unit cell of K space of you may call it the unit cell of reciprocal space. Just like real space has repeating units, just like in real space we have unit cells for repeating, and reciprocal space we have repeating zones. So keep in mind, all unique electronic information is contained in the first Brillouin zone. Maybe all the properties of the structure like total energy, electron density, density of state required integrating or the Brillouin zone. But the Brillouin zone contains infinite many KPoints, impossible to integrate exactly. Instead, we sample it with a finite set of KPoints and approximate the integral by the sum. Okay, so this is the main thing. Through this interface, we basically finite or the Brillouin zone to catch the first Brillouin zone for getting unique properties of electrons. Okay, so we have different methods for sampling, like here we have gamma points only. Here we have option with quality, in which we have coarse, medium and fine. And the next thing is separation, and the last one is customized grid parameters. From here you can customize according to your sample, according to your structures manually. When you click on customize grid parameters, so you can customize from here. You can customize your KPoints from here. Okay, so it's depend of your desire. It's depend of your structures. If your structure is metal, so metal have sharp Fermi surface, so that is why it's need dense grid points. If you have semiconductor or insulator, so energy is of semiconductor or insulators very smoothly, so you may take the course of the you can take loose KPoints. So you can take loose KPoints if you have supercells of your crystals. So that is why you also check the gamma points for. So I think so it's better to discuss one by one in detail. So this gamma points only means use only 000 KPoints, which is suitable for very large supercell. So okay, so the next thing is quality. By checking the box of quality, we have different options: coarse, medium and fines. So through this you can automatically set the grading points. The next thing is separation. Separations can be defined grade density by distance between KPoints. This is more physical, scale naturally with cell size. And the last thing is customized grade points. So from this grade points you can customize manually. The next thing is actual spacing. So this is basically the real KPoints spacing. These value are resulting from your chosen grade. So through this you can get the real space value by choosing these grade points in reciprocal space. And the next thing is origin shift. Here we have 0 0 0, so this is basically 0 0 0 is the gamma points. So origin shift means shift the KPoints grades away from gamma origin. Okay, so gamma points is basically the origin of Brillouin zone, and by customizing grade points, so from this step you can get the shifting information of your grade points from the origin. And the last, we have option with the display points. By clicking on it we get this type of interface. So through this display points button you can see the actual list of KPoints in CASTEP which you are using for your calculation. Okay, so these all information about KPoints. Next we will discuss about potential and DFT plus D. So keep in mind. Thank you for watching, and be with me. I will discuss one by one briefly.